Okay, hi everyone, my name is Kyson. Welcome back to the STEP Project YouTube channel. I just wanted to go over an alternate solution to 1994 Step 1 question 8. So let's get straight into it. So previously we were asked to work out some integrals, and you might have noticed that the upper bound here is pi over 2, and this lower bound here is 0. Now, with the integrals that we calculated before, we had that the integral from 0 to pi over 4 of, what was it, of ln 1 plus tan theta d theta, we found that that was equal to pi over 8 ln 2. Okay, we're going to use this fact to find another substitution that links to this new integral here. So if we look at our bounds, and if we stare long and hard, if we set x equal to 2 theta, we get something with those bounds being the same, and then hopefully we can sort of do some algebraic manipulation and get to something that's very similar to this. So let's get straight into it. So our integral, if we let x equal 2 theta, that means that dx is equal to 2 d theta. So our new integral becomes, now if x equals 2 theta, when x is 0, our lower bound is still 0. Okay, it's going to have 0. And then when x is equal to pi over 2, we have x equal pi over 2. But remember, x is equal to 2 theta. And this was the whole point of the idea. We now have theta equals pi over 4. But then don't forget that 2 on the outside, and then we have 1 plus sine 2 theta over 1 plus cos 2 theta d theta. So now we're going to try and manipulate this integral. Okay, so we're going to have 2. Now I'm seeing 1 plus sine 2 theta. I should immediately be thinking compound angle formulae. So I've got here, so this is going to be 1 plus 2 sine theta cos theta over, oh, and I forgot the ln, apologies, ln, over 1 plus cos squared theta minus sine squared theta d theta. So I know that I'm looking for something that's similar to this integral here, okay? And to get a tan theta, I know I need cosine terms in my denominator. So I'm going to set the sine squared theta to be 1 minus cos squared theta. So remember, sine squared theta plus cos squared theta is congruent to 1. So that means sine squared theta is congruent to 1 minus cos squared theta. So I'm just going to sub that in there on the top, on the bottom, sorry. This should be ln 1 plus cos squared theta minus 1 minus cos squared theta d theta, to then have the integral from 0 to pi over 4 ln 1 plus 2 sine theta cos theta over, now I'm going to have 1 minus a 1, okay, so that's just going to go away, and then I'm going to have cos squared theta minus cos squared theta, so I'm going to have 2 cos squared theta d theta. Okay, so now this is where it requires the slight stroke of genius. So this 1 here, I can write as sine squared beta plus cos squared beta. Okay, so if I substitute that into here, I now have 2 times the integral from 0 to pi over 4 of the natural log of sine squared beta plus 2 sine beta cos beta plus cos squared beta over 2 cos squared beta d theta. Now, because I want to manipulate my log laws, I'm going to do something really nice here. I'm going to say this is 2 times the integral of ln a half multiplied by this monstrosity. No, that 2's gone, so now cos squared beta. Because I know now later on I can split that up and use my log laws. Now, the numerator of this fraction actually factorizes. This factorizes to cos beta plus sine beta squared, if you think about it. Okay? Because I'm going to have that cosine term and I'm going to square it, and then I'm going to have cos theta sine theta twice, and then I'm going to have that sine theta squared. So this becomes integral, and then we have cos beta plus sine beta all over cos beta squared d theta. So now I can start using my log laws and splitting this up. So I'm going to have ln 1 over 2 plus ln cos beta plus sine beta over cos theta. And now, and this is squared, you should be able to see where we're going with this, because now I can split this up d theta 2 times, well, the integral from 0 to pi over 4 of ln. If I split this fraction up, I can split this fraction up into cos theta over cos theta plus sine theta over cos theta, which is 1 plus tan theta. So I have 1 plus tan theta, and that squared can come down, and this becomes a 4. Okay, d theta. Using our log laws. Okay, so let's just integrate this. So this is going to be theta ln 1/2 evaluated at 0, 2 I should say, pi over 4 plus 4 times, and we already know what that integral is going to be. That is going to be oh, we had it up here, didn't we? Pi over 8 ln 2, so pi over 8 ln 2 valued at 0 and pi over 4. When I plug in 0, I'm just going to get 0, so this is going to become pi over 2 ln 1/2 plus 4. Lots of, again, when I plug in 0, I'm just going to get 0. When I plug in, oh, sorry guys, I've forgotten. Oh, yeah. Whoa, what am I doing? What am I doing? We've evaluated this integral, so there's no bounds. Okay, there's no bounds. That is the integral evaluated. So now we have pi over 2 ln 2. Now you might be thinking, can this be simplified? Yes, it can. Because a half, what is a half but 2 to the minus 1? Now if we use our log laws, this becomes minus pi over 2 ln 2 plus pi over 2 ln 2. And that is, of course, equal to 0. Okay, so an alternative method there, it is slightly longer than the recommended video that was given before this one, so I do recommend giving that solution a go, and I recommend using that solution. But it is always nice to think about other ways to solve problems because they might help you with future problems. So yeah, I hope you guys enjoyed this one. I'll see you guys in the next video.